Today, we're tearing down the invisible architecture that keeps our entire digital world from collapsing on itself. We are talking about scalability. It's the art and really the science of handling growth, and it's a story of constant crisis and radical evolution.
So, what is that force? Well, the answer isn't just some clever piece of tech. It's a wild story of crisis, revolution, and a future that looks less like building a bigger machine and more like creating a global brain. And to really get it, you have to go back to the beginning, to the very first crisis that almost broke the web.
You know, in the beginning, things were beautifully simple. You had a website, and you had one server that ran it. That's it. But as the web just exploded in popularity, that simple model turned success into a company's worst enemy. The very users you were desperate to attract were the ones who were literally crashing your service.
And if you look at this timeline, you can see the whole history of scalability is really just a story of reacting to pressure. Before the web, these big centralized mainframes were plenty, but the explosion of the early web in the 90s, that brought a tidal wave of users. And that one server to rule them all model, well, it was about to get completely shattered.
The first and most obvious solution was something called vertical scaling, or scaling up, and the logic was pretty straightforward. If your server is slow, just make it bigger, stronger, add more RAM, a faster CPU, more storage. You just keep upgrading that one single machine.
But this was a trap, a fatal one. For one thing, you eventually hit a hard physical limit. You literally can't buy a bigger computer. Second, the cost just becomes astronomical. But the deadliest flaw, the real killer, was the single point of failure. If that one super expensive, maxed out machine goes down, your entire business goes down right along with it. Game over.
And this wasn't some academic theory, not at all. The stakes were massive. By the early 2000s, a titan like eBay was running its entire global auction house on one single, gigantic database server. And that server was audibly groaning under the weight of its own success, getting closer and closer to catastrophic failure every single day.
So clearly, something had to give. A whole new strategy was needed. So instead of relying on a single fragile giant, the industry turned to the power of the swarm. This was the beginning of the horizontal revolution.
So instead of trying to build one invincible superhero server, the new idea was to create an army of them. This is horizontal scaling, or scaling out. You distribute the work across a whole fleet of smaller, cheaper, off-the-shelf machines. Now, if one fails, who cares? The others just pick up the slack. All of a sudden, the potential for growth became, at least in theory, totally limitless.
Now, this new architecture was built on a few, honestly, brilliant ideas. First, you've got a load balancer. Think of it like a digital traffic cop, sending users to whichever server has capacity so you never get a traffic jam. Second, services became stateless, a super powerful idea that just means any server can handle your request. That way, if one goes down, you're just rerouted to another one instantly. You don't even notice. Third, those giant, clunky applications were broken into tiny, independent microservices, one for billing, one for logins, so a problem in one area wouldn't crash the whole system. And finally, the data itself was spread out across many databases, which completely eliminated that single point of failure.
And you know who absolutely weaponized this new blueprint? Netflix. Their story is just a masterclass in how to turn a devastating crisis into a massive competitive advantage.
Back in 2008, Netflix learned the lesson of the single point of failure the hard way. A database corruption took their entire streaming service offline for 3 days. 3 days! In internet time, that's an eternity. It was a complete catastrophe. But it was also a catalyst. They made an incredibly bold decision to abandon their old model entirely and spend the next 7 years rebuilding their whole platform from scratch, for the cloud, using horizontal scaling. And the result? Well, this number really says it all. 99.99% availability. That's what we call 4 nines. It means less than an hour of downtime per year. And the genius of it was, they didn't try to prevent failure. They planned for it. They engineered a system that embraced the idea that individual parts would always be failing.
So what was their secret sauce? They just broke their system into hundreds of tiny little pieces. See, Netflix isn't one big application anymore. It's a collection of over 700 independent microservices. The recommendation engine is totally separate from the billing service, which is separate from the video streaming itself. And what that means for you is, if the recommendations fail, your movie doesn't stop.
But here's the twist.
Just like before, the solution to one crisis planted the seeds for the next one. The horizontal revolution gave us incredible resilience and scale, but it came at a steep price, a crushing, almost incomprehensible level of complexity.
This quote just nails the new problem perfectly. It's called the scaling paradox. See, when you add more servers, you get a linear increase in power. That's good, but the complexity of managing all those servers, that grows exponentially. All of a sudden, your ability to simply understand your own system becomes the new bottleneck.
And that complexity has very, very real costs. We're talking about the immense cognitive load on engineers who are just trying to keep these sprawling systems running. And then there's the staggering and frankly unsustainable growth in energy needed to power all of these hyperscale data centers.
Just look at this number. Data centers are on track to drive over 20% of the growth in global electricity demand by 2030. Think about that. The very model that powers our cloud is on a direct collision course with the physical limits of our planet. Brute force scaling is hitting a wall.
And that brings us right to the edge of the next great revolution. Because the future isn't about choosing between the centralized giant and the decentralized swarm. It's about figuring out a way to fuse them together.
So, in this future, you absolutely still have the massive power of the centralized cloud. Let's think of it as a supernova, this incredible point of gravitational pull where these huge foundational AI models are trained and all the global coordination happens.
But, and this is key, that power is fused with the starfish, a decentralized, resilient network of intelligent devices out at the edge. We're talking about your smartphone, your car, sensors, all processing data locally. Just like a real starfish, if you cut off a limb, the organism survives. It's the exact opposite of a single point of failure, because intelligence is distributed everywhere.
And when you fuse these two ideas, you get what some are starting to call the Symbiotic Singularity. It's a totally new kind of global computer, a single system that is somehow both centralized and decentralized at the same time. But here's the most radical part. It won't be managed by people. The complexity is just too great. It will be managed by an AI orchestrator.
Now, this isn't going to happen overnight. It's more of an evolution. First, AI will master managing the central cloud with superhuman efficiency. Next, that intelligence will spread out to the edge, to billions of local devices. And then, in the final convergence, a single AI will manage the entire system from the core all the way to the edge as one single cohesive whole.
So our journey brings us to this final critical shift. We're moving from a world where we had to scale servers to a world where we have to scale intelligence itself. And that leaves us with this provocative and profoundly important question. The technical challenges, yeah, they're immense. But the challenge of trust, that might be even greater. We've built a world that can no longer run without scalability, and we may soon find ourselves with a system that can't run without a non-human intelligence at its very core.